Marian, and please put away your phones. Okay. All right. While you are doing that, ladies and gentlemen, please take out your computers, get logged in, and go to joinpd.com. Joinpd.com so that we can get moving today. While you're doing that, I'm going to take attendance. Oh my. Myra, gotcha. Susan, yeah. All right. Leslie, yep. All right. Cynthia, yes. Marissa. No, Marissa. What? She's here this morning and she ditched my class? Brianna. Festino. That's what it's there for. Go ahead, sir. Jordan, got you. Virginia. Esmeralda. Thank you. What? What about it? I'm sorry. That's not my... I have no control over that. What do you need? I will go check in the back. Give me a minute, please. Tredarius is not here. Natalie. There you are. Thank you. Amarian. Watch your language. And by watch it, I don't mean actually watch it. I mean choose other terms that are not so inappropriate for school. No, you're not Amarian, are you? You might have been swearing too. Were you swearing?
She was swearing, teacher.
Mr. Brain. Brain. B-R-A-N-N. Hang on, I can't read that. Joinpd.com? Try it again because it shouldn't be blocked. Yeah, you might have accidentally, and that'll make a big difference. Calvin. What? I don't know, but obviously something that they don't want you going to because it was blocked. No, you want to get in trouble for it or what? No.
Hey, on my mama, y'all not
18, 3, 4, 5, 6. 17. Who am I missing? Marian, Natalie, Virginia. Sorry, I'm missing somebody, so I'm trying to figure out who I'm missing. Fustino. Okay, sorry, I'm missing somebody. I'm trying to figure out who it is in attendance. Brianna, Marissa. Oh my. 1, 2, 3, 4. All right. Who needed a charging block? I'll see if I got it back. All right. We need a charging block coming up and grab one.
Yep. Better go get you one. And you better go get you one.
Jordan. You didn't say anything when I asked.
Raise my hand.
Did you?
Yeah.
Oh, I'm sorry. Then I missed it. I'm working on it. If she would have her computer charged, I wouldn't have to go get her one.
It's because she couldn't get up herself. You're literally going to give you one. I'm also one of the Wow.
Yes. I do say.
No, she wanted me to get up and get a portrait.
What? You would have done that?
No.
Okay, I don't blame you. All right, ladies and gentlemen. All right. Couple of things as we get going today. Number 1. Tomorrow is your first quiz. Tomorrow is your first quiz. Sorry, I thought I said it clearly enough, but obviously I'll repeat it. Tomorrow's your first quiz. It covers vocabulary and the definition of chemistry. the definition of matter. And it is a few where you are going to have to type in an answer, and somewhere it'll either be multiple choice or matching. Okay? Now, I am telling you, one of the two questions for the, you have to type it out, is the definition of chemistry. Now, again, on the quiz, you may use your periodic table. And when I gave you the definition of chemistry, the first thing I asked you to do is write it at the top of your page. Why? Because I'm going to ask it to you on your first quiz. I'm going to ask it to you on your first test. I'm going to ask it to you on your second test. I'm probably going to ask you on your third test, and I may ask you on your fourth test. Yes?
Why do we have to know the definition of chemistry?
Because you're in the class, I think you should. If nothing else, I want you to be able to define that to somebody else somewhere down the line.
What's the definition of chemistry?
And actually, you don't have to memorize it. Why? Because it's on your periodic table. Are you ready? I'll give you this one shot. Are you ready?
No.
You ready? Okay. The science of the study of matter, its properties, structure, composition, and the changes it undergoes. That is the definition that will get you 6 points on your quiz. Yes.
I just forgot already.
There you go. Ladies and gentlemen, there are always extra periodic tables over here. Feel free to grab one anytime you need it. Anybody need one as long as I'm here?
What he just told me.
Okay. So, again, for those who just asked me what the definition of chemistry is but can't remember it because it happened 2 seconds ago, in your Unit 1 EISN, on the second page, there is your definition of chemistry. You can find it there. You can copy it down. You can put it on the top of that periodic table. Again, it's going to be a 6-point definition on your quiz tomorrow. And that's out of about 18 points on the quiz. I don't think it's a 20-point quiz. I think it's only like 18. So this is literally a third of your grade right here. Just putting this definition down. Okay? Questions? Okay. So I asked you to go to joinpd.com, ladies and gentlemen, so that I can give you this code. By the way, this is LSLQFT. Those are L's. I know they sometimes look like capital I's, but those are L's. LSTQFT. If you could type that in and hit continue or enter or whatever it is you have to hit, it will log you into the Pear Deck so that we can do a little bit of reviewing for your quiz tomorrow.
Teacher, do you have any periodic tables?
Yes, they're right over there. Yellow one. 4th letter tray from the bottom.
Thank you. Hey, stop pulling me.
All right. So in an experiment, the experimenter lets the water sit on a hot plate for 5 minutes. And the temperature of the solution goes up 5 degrees. The change in temperature is what kind of variable? Is it the independent or is it the dependent variable? You can simply take your marker and put it over whichever word you believe it is. You can put it over independent or you can put it over dependent, whichever one you think it is, ladies and gentlemen. Now, again, if you choose not to participate and if you choose to put your icon up after I show you, that's fine. But when this is a question on the quiz tomorrow, that's when I'll find out if you know it or not. So, few people on independent, more on dependent, which is good because the correct answer is that is the dependent variable, ladies and gentlemen. Okay? Independent variable is the variable the experimenter controls. And it says the experimenter lets the water sit on the hot plate for 5 minutes. That is the independent variable. The one that you control, the one that the experimenter controls is the independent. Also, another way of memorizing it or another way of knowing it is this would be measured before the change in temperature. How long you put it on there? The one that is measured first is always independent. The one that is measured second is always dependent. Questions?
Oh, I know it now. I'll tell you right now. Wait, I don't need. Wait, is it on?
You're gonna tell me the answer to the question that I just showed you, or
I'm
what?
gonna tell you the definition of chemistry.
Okay, later. I'll let you know when. Okay? Now! Okay, you can't do it. Something in an experiment that does not change is called, pick one of those options that is there, ladies and gentlemen. One of those 4 options. Something in an experiment that does not change.
Who clicked it? No.
I could tell you, but I won't.
And very smart.
Okay. Smart, but wrong. The correct answer, ladies and gentlemen, is a constant. Something that doesn't change is a constant. Okay? So if it doesn't change, it's a constant. Okay? An educated guess in the form of an if-then statement is called A or N what?
Answer. See, click control. Both of them press control.
Okay. Hypothesis is the correct answer, ladies and gentlemen. Very good. Again, some of these should be really easy for you because you've had them for every year for the past how many years? Okay? Give an example of a qualitative observation. Type in any example of a qualitative observation. You can make one up. You can look around the room and pick something out. You can make it over something in the front of the room. Give me an example of a qualitative observation. I'll give you a hint. That was what we did in class on Thursday with that activity near the end, where we had the plate full of objects. You made qualitative observations in that.
Good answer. The wood is brown.
Okay.
The scissor? Who just spelled scissor?
As long as your observation, ladies and gentlemen, excuse me.
Yeah, who just spelled scissor? S-I-S-O-C-R-E. You should tell me like that. There's no way. Oh, that's fine. You're supposed to be.
It'll be fine. Okay.
I'll continue it.
Okay. Well, you probably are going to have a hard time because it's I control how fast it goes.
Oh.
But we'll see. Okay, so yellow pencil, smooth desktop, shiny metal legs on a desk. Hand sanitizer has a nice. What's wrong with that one? Hand sanitizer has a yeah. It's supposed to be odor, not order. Okay. The candy tastes sweet. Reaction makes a fizzing sound. Okay. So remember, what is the key to something being qualitative? What is the key to something being qualitative in an observation? Using your 5 senses. Okay, using your 5 senses. Very good. Any quantitative data must contain a what? Quantitative data or a quantitative observation must contain a what to be quantitative?
What if there's both of them in it?
Well, you can't have an observation that could be both quantitative and qualitative.
Can I put both of them for this?
No, because I want to know what a quantitative data must contain. Okay, quantitative data must contain a number.
In a form.
Whether you write it as a as written out TWO or write it out as the number. Quantitative has to have a number with it. Qualitative does not have a number with it. So all those things a minute ago, sharp pencil, odor, fizzing sound, taste sweet, those are things that we can do without putting numbers on them. Okay? So numbers are quantitative, no numbers are qualitative. And Amarian is correct. You could write an observation that has both. 12 white eggs. 12 would be the quantitative, white eggs would be the qualitative, so it is possible that people could write a observation with both. Okay, good. Stopping there. Questions?
Teacher, you look like mad chicken.
Okay, so questions? All right. All right, so then, ladies and gentlemen, where we're at right now, get into your EISNs and get to slide number 11. Slide number 11 in your EISN. Okay. So I am going to play you a sound. It is a name. And after I play you the sound, I want you to tell me what name you heard said. Now, this is what kind of an observation? Qualitative. So based on what you hear, you are going to tell me what name you heard said. Are you ready?
Mm-hmm.
All right, here we go. What name?
Lori.
What? Laurel. How many of you heard Laurel? Okay, Luis, what do you hear then?
I heard Lauren.
You heard Lauren.
Yeah.
Like Lauren.
Okay, Faustino, what'd you hear?
I heard Yanni.
You heard Yanni?
Something like that.
How many of you heard Yanni?
Johnny.
Those are the two things you should have heard.
Oh, I hear neither.
You either heard Laurel or you heard Yanni. Okay? You either heard Laurel or you heard Yanni.
I heard.
Please listen. Here it is again. There are a lot of people who, when they hear this name or this name pronounced, I hear Laurel. Other people hear Yanni.
We're fighting both.
Well, and I guess you're doing okay because I've gotten to the point where I hear a little bit of both. Normally I hear the start of Laurel and then I hear Ani at the end sometimes. But there's a reason for it. And two people would listen to the same clip and hear totally different names. Okay? The two names that most people hear are Laurel or Yanni. So this is the explanation for it. So part of it is in the way we hear. And some people hear different sound ranges compared to others. The point is, no matter what, whether you hear Laurel or whether you hear Yanni, you're hearing the same sound. It is the same recording. It is not any different for one person than another. Okay? So, a psychology expert say that an illusion happens when the brain can't decide on exactly what it is hearing. So it's kind of like you're in between the two and your brain is forced to make a decision as to what you heard. Okay? So again, it all depends on the frequency. It all depends on the audio clip you hear. But there are times where two people can hear the exact same word and get two different meanings from it. Okay? All right. Okay. Take a look at this slide, ladies and gentlemen. Now, In a minute, I'm going to ask you to tell me what color dress this is. Okay, so take a look at it. Hey, first of all,
Shut the frick up.
thank you, much better.
It's white and gold.
Okay, how many people see a white and gold dress?
What is wrong with
How many people see a black and blue dress?
Bro, y'all get more excellent. Y'all need to get checked out.
I see white and gold. Clear as day, I see white and gold. All right? So how could two people look at the same dress and see different colors?
Because they colorblind.
No, this is not a colorblind thing. Now, black and blue are sometimes hard to distinguish for a person because they are colorblind that way sometimes. And there are different kinds of colorblindness where you may not distinguish two different colors. This is not one of those things. This is not if you're colorblind, you're seeing white and gold. If you're not colorblind, you're seeing black and blue. This again is your brain processing what you're seeing. Okay? So there is an explanation for it. Here it is. Sorry, I meant to pause that. Okay, we're not doing well here. Hold on.
This girl's purple.
Okay, what color does that block right in the middle appear to be to you?
That's brown.
Brown?
You're like a Brian.
That's
Like a brown? Yes? No?
that's blue.
Black. What?
I see a yellow or orange here. I see brown up there. Okay, now here's what I will tell you, ladies and gentlemen. I see black and blue. I see black and blue. This does not look like the same dress to me. Again, maybe you see all three of these as the same color, but I see the one at the top nowhere near the color of those other
I
ones.
see orange.
Okay? Can't help you then because you're seeing something that I don't see there either. Okay? All right. So, what this means, ladies and gentlemen, there are times where you can't trust what you hear. There are times where you can't trust what you see. So does that mean that qualitative observations aren't any good? Because those are all based entirely on your senses, correct? What do you need, sir?
I got it on the map, bro.
Go punch out and go. Hurry up. Okay? So again, ladies and gentlemen, does that mean we cannot rely on qualitative observations? What do you think? Can we rely on them? Yes, we can.
Yeah.
You sure, Luis?
What'd you say? We can depend on our.
Can we rely on qualitative observations?
Yeah.
Okay, simple question for you. I'm glad you spoke up, Luis.
Yeah.
What color shirt does he have on? Red? Anybody else? It's maroon. Anybody else? How come we got two different colors?
You probably know the word.
Possible. I work out of the box of 8 crayons a lot. Okay? I don't know what color all the colors are. Right? Anyone see another color other than maroon?
Black.
Black? There's some black in there. I would agree with that. Have you ever gone to a place like Kohl's where they sell perfume and things? Sprayed one of the perfumes and thought, oh my God, that is the worst smelling thing you've ever smelled? Yes?
Yeah.
Why did they sell the worst smelling cologne ever? The worst smelling perfume ever?
Some people like it.
Thank you. Some people like it. Now, 2 people should be able to detect an odor. Whether you like that odor or whether you don't like that odor, that is entirely up to you. Okay? The same thing when you talk about taste. 2 people could taste the exact same food, and one say that it's spicy, one say that it's not. One could say that it tastes good, one could say that it tastes bad. When you talk about things that are based on our perception, then how you feel about something comes into play. Does that mean that we can't use that for observations? No, it doesn't. But it just means that if 2 people were to look at Luis's shirt, you might get 3 different colors based on what the person sees. Based on if the person is someone who's into art and could maybe give us a better color than even maroon for that. Okay, or they're into fashion and they can tell that. The point being, ladies and gentlemen, when you're talking about qualitative observations, it's based on what you see, what you smell, what you hear, what you taste, and what you feel. Okay? Some of you felt the objects the other day and some of you said they felt smooth. Others felt the objects and said, that's not smooth. Again, it's based on your perspective. Okay? It's based on your perspective. So we've got to be careful because in science, we make observations all the time. Questions? Okay, now, the other kind of observations that we make, not qualitative, are called what again? Quantitative. And quantitative observations have to have what? Numbers. The only way you can make a quantitative observation is to use one of the things that you see on the board. Now, I'm not asking you what those are specifically called, but what are those things in general that we take measurements with called?
Balance.
These are a balance. You are correct. But a balance, a ruler.
Scale.
Oh, starts with an I. The band plays them.
Instruments.
They're called instruments. When you use an instrument, ladies and gentlemen, now you have to get a number. Now, Jonathan goes up to the balance with his water bottle. He puts it on there. He gets a mass. Okay? Evelyn grabs his water bottle, goes up to the balance, puts it on there. She gets a mass. What should the masses be? They should be the same. They should be the same. But Evelyn and Jonathan taste the same food, and they may have different opinions of it. But when you take measurements, ladies and gentlemen, there should be no doubt about it. No doubt about it. Now, here's what I expect. Every time we give you an instrument, you should know what that instrument measures, and you should know what unit it measures in. So that is what you are seeing up here. This unit, this instrument, I'm sorry, is called a balance. Now, balances are used to take the mass of an object. That is what they do. And the unit for that will be grams or kilograms. Okay? That is the unit that you will use for this. Okay? So we're going to go through a few instruments, show you what they measure in things, and then we're going to talk about them in just a few. So, all of these instruments used to measure what?
Length.
Length. Specifically, we could be something a little bit more general, because normally if we talk length, we're talking here to there, correct? What if we go from the floor to here?
Height.
But our height and length measuring the same type of measurement.
Distance.
They're both measuring distance. Thank you. So if you are measuring the height, the length, the width of an object, any way you look at it, you're measuring distance. If you're measuring distance, you are using some sort of an instrument like a ruler, a meter stick, a ruler, a tape measure. This is called a micrometer, ladies and gentlemen. This instrument here could measure the thickness of a hair on your head. It's for measuring very, very, very small things. Okay? So all of these are instruments used to measure distance. Now, in our system in the United States, give me a unit for measuring distance. Calvin, give me a unit for measuring distance in the United States.
What type of distance?
Your height, let's say. What would they measure your height in? Right? That's the instrument they would use. I'm asking you, so how tall are you, Calvin?
12 inches.
They use either feet or inches. If you're measuring the distance from here to Chicago, do they use inches?
No,
Do they use feet? What do they use?
no.
Why?
Bigger.
Because it's a longer distance. So we have units that we are going to use depending on what we are trying to describe. Something small, we may use inches. Something a little bigger, we may use feet. Something a little larger, we may use miles. Okay? In the metric system, they use kilometers, they use centimeters, and they use millimeters. And also they use meters. Those are the distances that they use in the metric system. Okay, what does this instrument measure?
Time.
Time. This instrument measures time. Stopwatch, right? Now, time is the one unit of measurement that's a little bit weird. Okay? It's the one unit of measurement that's a little bit weird because how many seconds are in a minute? 60. How many minutes are in an hour?
60.
How many hours are in a day?
24.
All of a sudden you switched on me. It was 60, it was 60, then it was 24, right? That's the weird thing about time. Okay? Time has different units, but they don't easily translate to one another. Centimeters, millimeters, kilometers, meters, those easily transfer to each other. Not that way with time, ladies and gentlemen. Okay? Can you give me another instrument that we could use to measure time besides the stopwatch? Timer, clock, yeah. Anything like that. Okay? Anything like that.
The same thing.
Right? All right. So these two instruments measure temperature. They're thermometers. This is a digital thermometer. This is an old-time thermometer. Okay? Now, the weird thing about temperature, ladies and gentlemen, is there are actually 3 scales in the temperature system. There is one that is called degrees Celsius, one that is called degrees Fahrenheit, and one that is called Kelvin. These two scientists, Celsius and Fahrenheit, they created a thermometer in the exact same way. They put a liquid into a glass tube, and they put that liquid in boiling water. What happens to most things when they get heated up?
They become fragile.
No,
Boil.
no.
Explode. They get hot.
They do get hot. And when things get hotter, they
Expand.
expand. So in this glass tube, these scientists knew that if you put it in boiling water, it was going to expand and go up the tube. And both of them took and made a mark where the water level was when it was in boiling water. Then they took that tube and they put it into cold water. Ice cold water.
Went down, shrunk.
It shrunk. They made a mark there. And both of them said, okay, I'm going to base my scale off the freezing point and boiling point of water. Why? Water's around on Earth all the time. Everywhere. What's the boiling point of water in degrees Celsius? A nice, easy number to remember.
100.
100. 100. So Celsius made a mark there. He said 100. That's what I'm going to call that. Fahrenheit did the same thing, but he chose a different number. What did he choose to be the boiling point of water?
200.
A little more.
225.
Too much.
215. Bang.
Still too much.
210.
What?
205.
Too low.
210.
Too low.
212.
212. He used 212. Now, I would love to tell you why he picked 212, ladies and gentlemen.
You know why?
I honestly don't know why he picked 212. But he did.
What Calvin picked?
Calvin? Calvin looked at temperature differently.
Mm-hmm.
He didn't look at temperature as to how much things would expand and contract. He said if something is expanding, it is because it is moving how? Moving faster. He based temperature on the movement of the particles in matter. The faster the particles move,
The hotter it is.
the hotter it is.
The slower the colder.
So his temperature for boiling water was 373
What? 73 what?
Kelvin. No degrees. Just Kelvin. 373 Kelvin. 373 K.
No Kelvin with an S, just Kelvin.
Just Kelvin. Just Kelvin. Hurry up. All right. What's the freezing point of water according to Celsius?
0.
0. So again, his scale nice and easy. Water freezes 0, boils at 100. I'm just going to divide the area up into 100 marks. Type in your ID number.
Come on.
No, it ain't going to take it. Here you go. There you go. You're welcome.
80.
Okay. So what did Fahrenheit pick for his freezing point of water?
I mean, if it's 212, I'm assuming it's going to be half of that, so like 106.
Nope. 32.
What the fuck?
He picked 32 degrees. Again, don't ask me why. That's the number he picked. Here's 32,
No.
here's 212. I'm going to divide it up equally, 180 increment.
How did she know that?
What?
How did she know that?
He didn't. He picked water
How did she know that?
because this is what we report what in outside every day.
She cheated, bro. She got something. She got her phone.
Hey,
She literally.
it's
No,
okay.
she
Some
never
people
ate.
know things. By the way, 32. Why is that important for us?
Oh, because 32 degrees.
Why?
That's when rain freezes.
Yeah, that's when it will snow outside. Because if it's below 32, it's below freezing. What did Calvin use? He used 273. He used 273. All right. Tough math question of the day. Tough math question of the day. You ready?
Easy. I got it.
You got it?
I got it.
Okay, you got it. All right. Sorry, I'm just getting some names down here. Susan, you ready? 100 minus 0.
Negative 100.
100. You ready, Amarian? You got this? 373 minus 273.
373 minus 270 is 100.
Good. So 100 degrees here,
Is
100 here. What that means is every time the temperature goes up 1 degree Celsius, it also goes up 1 Kelvin. The numbers are just higher, but it's still 1 degree Celsius is equal to 1 Kelvin. Okay? Now, what is absolute zero?
Negative 273.
But what is it? I didn't ask what the temperature was. I asked what it is.
Absolute zero is like below zero.
Good. Anything that is below 0 would be below 0. But what is absolute 0?
Like the coldest something can be.
Correct. It is the coldest something can be, and it came to us because of Kelvin's scale. Now, Kelvin said he was measuring temperature by how what the particles were fast.
And this is
So what is the slowest the particle can be?
0, not moving at all.
0, not moving at all.
0 Kelvin.
0 Kelvin.
Well, you need to go get one. I'll sign in there. Thank you.
Okay. So absolute 0, ladies and gentlemen, is the point where particles in matter stops moving. You cannot get any colder than that. You cannot get any colder than to cool something down to where the particles in matter stop moving. Okay? So in this desk up in the front, in your desk in front of you, there are particles of matter that are literally vibrating back and forth.
Because of you.
No, because that's what particles do that have any kind of heat in them. They move back and forth. So if you cool them down enough, you will get them to the point where they will stop moving. And if they stop moving, that is called absolute 0. Now, in Celsius,
I know.
minus 273. In
I
Fahrenheit,
know. Let me see. I know.
define chemistry.
Define chemistry.
Okay, minus 459,
wait.
ladies and gentlemen.
The science of the study, right, of matter, its structure. Help me out, bro.
3 out of 6 points on the quiz so far.
Properties.
4 out of 6.
Composition.
5 out of 6.
And the changes it understands.
So close.
Undergoes.
Now you got 6 out of 6. Good. By the way, think about this, ladies and gentlemen. In winter, in Wisconsin, when it gets to be about minus 40, minus 50 degrees, they will call off school.
Yeah.
In Fahrenheit, absolute 0 is minus 459 degrees.
So multiply.
Minus 459 degrees. And people ask all the time, Mr. Brand, is that cold enough to kill us?
Yes.
Actually, we die long before that.
So we die like 100.
Because at minus 189 degrees Celsius, the oxygen that is a vapor in the air that we are breathing becomes a liquid. And there will be puddles of liquid oxygen laying on the ground, and we will not be able to breathe anything, and we will die at that point.
Unless you have suffocate oxygen on the ground.
Good luck. Okay? Good luck. Okay? By the way, if it ever got that cold, we would be dead anyway. We can't handle that extreme cold.
Happily.
Okay?
Happily.
By the way, what's the temperature in Kelvin?
0.
0.
Because it's not moving.
That's absolute 0. Yes, sir. Certainly, sir. Go ahead. Seems to be a convention going on right now.
I think you want to.
All right. This is a unit that we will hardly ever use in this class, ladies and gentlemen. It is called an ampere. That is the unit. It measures electric current, and it is measured by what is called an ammeter. We will never use these in this class. If you take physics, they will use them a little bit in there, but not much. But every one of your homes has something that is rated in amperes in it. That's the fuse box in your basement.
I don't got a basement.
Okay, that's a fuse box somewhere in your home.
Cross.
There's a fuse box somewhere in your home where if you turn on too many things at once in an electrical circuit, it'll blow a fuse. Every one of those fuses is rated in amperes. They're normally 10, 15, 20, 25 amperes. And if you blow them, you have to go up and you have to reset them. Yes, sir.
So is this the amount of wattage that?
Nope, watts are different.
So.
Watt is measuring something totally different. They both have to deal with electricity, but watts deal something totally different.
So it's not. So would it be? Would it be like how much a meter? Ammeter?
It would be like saying a meter, which measures distance, and pounds, which measures weight. They're two different measurements. They're telling you two different things.
So how much a meter, right, would you need to blow a fuse?
The amperes are a number, 10, 15, 20, 25. If you turn on your microwave, that draws a lot more electricity which means higher amperes going through the line. Okay? So if you turn on a microwave and a blender, two objects that take a lot of electricity, and a vacuum cleaner, you may blow a fuse if they're all on the same breaker. Because all three of those things have motors in them that require more electricity.
I want to test that.
Every electrical device has a certain amount of amperes that it draws. All right. This is a light meter, ladies and gentlemen. It is used to measure light intensity. Light intensity is something that you can measure. The unit is called a candela. By the way, what does candela sound like?
A candle.
Yes, because literally,
Light.
when they first measured light, you would put a candle in a dark room, you would light it, that would be one candela of light. You put in two candelas, three candelas. The more candles you had, the brighter the room got. That was how they measured it,
That's not true.
compared to candles. What's not true?
The more candles you have.
So if you put 5 candles in a room compared to 1, it will be brighter in that room, 5 times
It
brighter.
depends. It depends.
No, it doesn't.
It depends how big the room is.
The bigger the room,
The less.
not the less brightness. Okay? The brightness will double if you have 2 candles in the same room, no matter how big it is. That'll have a harder time lighting up the whole room, but the brightness will still double, relatively speaking.
Relatively, but
Yes.
not
Okay.
scientific.
All right. So the last one, ladies and gentlemen. By the way, there's only one profession that I've ever seen use these.
Oh, I know.
Go ahead.
The lighters. The electricians.
They'll be back here on the 13th of September.
The electricals.
Photographers.
Oh.
Photographers have light meters with them so they can adjust the lens on their camera so that they can take the best picture.
So it's not the people that put the lights in the ceiling?
No.
That would really make sense.
Nope. So, nope, not them. All right, this last one, ladies and gentlemen, is a unit that gets used a lot in chemistry, and it is called the mole. It measures the amount of substance, okay? If I told you that I bought a dozen donuts, how many did I get?
12.
12. If I bought a dozen pencils, how many did I get?
12.
If there were a dozen notebooks, how many?
12.
Why?
Because a dozen is 12.
Good. A dozen always means 12. It doesn't matter what you put after it. It means you have 12 of something, correct? Yeah. Okay, can you think of another term in our language that means a specific number of something?
Duo.
Duo. How many?
2.
2. Good.
Trio.
But would you ever talk about a duo of skateboards?
I mean, a duo. Duo of skateboarders.
Well, a decade would mean what? 10 years. And we do use that term to describe 10 years. But what I'm trying to say is it's a term that could be used with a lot of different things. So we would put it in front of students, in front of notebooks. We would put it in front of glasses.
Double.
A double student.
Hey. Maybe you go to 2 different schools.
Single, mono.
Mono and single do mean one, but you don't often hear there's a mono student over there. But you will hear there's a dozen golf balls. There's a dozen eggs. There's a dozen donuts.
There's a half a dozen.
What if we have
Half a
2
dozen.
of something? Half a dozen means how many?
6.
Good. 6. We use that. What if there are 2 of something? No.
Double dribble.
Okay, I'm not arguing that point with you. A couple.
Oh.
A pair. That means
Yeah.
2 of something, correct?
A bunch.
How many is in a bunch?
A bunch.
See, and that's the thing. You
4.
got to be careful because we have terms that we use like bunch, few, several.
Some.
But
Some.
some. Is it describing a specific number though?
I mean, it's only. It's
What is?
Bunch.
Is that the
A bunch is 5 or more? Yeah, that's the EIS.
EIS.
What?
A bunch is 5 or more.
A bunch
more,
is
more.
is 5 or more. Where'd you get that from?
Google.
But it doesn't describe a specific
Yeah,
number then, does it?
Or more.
Or more.
Is it 5?
Yeah. Or more, but the or more is the part that ruins it.
Uh,
Mole describes a specific number of something, like a dozen eggs. Here's the number, ladies and gentlemen. 6.02 times 10 to the 23rd.
which is 23rd power?
Yep. Now, real quickly here, ladies and gentlemen. This number right here is in what place on the number line?
Well, that looks like the thousands.
Not thousands. Thousands.
I said thousands.
Okay, sorry. That's where my wife and I live. We're thousandaires, ladies and gentlemen. We have a few $1,000s in the bank. This spot right here is what?
Million.
Million. So if you get lucky enough one day to win the lottery, you will probably become a millionaire.
Mm-hmm. Well, not
now. Few people. Mark Cuban.
Billionaire.
Jerry Jones.
Million.
Bill Gates. I don't know if former President Trump is still a billionaire or not. Elon Musk. They're billionaires. What's the next one? Trillion.
Hey, I'd give you one. Me too.
By the way, trillion, that is the range of our national debt. That is how much money the United States owes as a nation, like $37 trillion. Okay? Anybody know what the next one is?
Quintillion.
What?
Quintillion.
You sure?
Yes.
Absolutely?
Yes.
Okay, quintillion.
That's what I'm talking about.
All right, what's the next one?
Xtillion.
Hex? Well, it's not hex.
Now you're guessing.
Isn't X5 or something like that?
I honestly don't know what it is.
No, not Quint. No.
But here's what I will tell you. I'm not even sure of this one, so I'm going to get rid of this one.
That
It is
was squad.
quintillion.
This is 1,000 trillions. This is 1,000,000 trillions. This is 602 billion trillions. That is an incredibly large number.
I swear it was quintillion.
If you, again, I don't know for sure, so I don't want to tell you wrong just in case.
That's a sextillion.
Sextillion?
Mm-hmm.
Okay. Point is, if you had that in pennies, it wouldn't fit on Earth.
Because
if you had 6.02 times 10 to the 23rd pennies, there would not be enough room on Earth for it. It would be larger than the planet.
It's quadrillion and quintillion.
Oh, what is it?
Quadrillion.
Because it's 4.
Okay.
I said that.
We're good. Okay.
Yeah.
Now,
You never said that.
I did say it.
No.
well, he said a lot of things. He gets it right by just shooting a lot of answers out there, and hopefully one of them hits once in a while. This is an incredibly large number, ladies and gentlemen. What do we have to measure in science that we need such a big number for? What do we measure in chemistry specifically that we need this big of a number for?
Atoms.
The sun.
Atoms.
The sun.
Atoms.
It is the sun.
Atoms. No, it's not the sun.
It is the
It's
sun.
atoms.
Because how many atoms is in the sun? Look at you. How many atoms is in the
So
sun?
in here, ladies and gentlemen, in this small container, I have 1 mole of magnesium atoms. Small enough to fit in your hand. Okay?
Well, you got 6 million.
So, this is how tiny atoms actually are.
You got 602 sextillion?
I got 602 sextillion atoms of magnesium right there in the palm of my hand.
Dude, Captain.
Alright?
Dude, Captain.
Right there in the palm of my hand. Now, this would be 602 sextillion molecules of sugar. Which one takes up more space?
That one because
This is much bigger than these. This is an atom, this is a molecule. This sugar contains 12 carbons, 22 hydrogens, and 11 oxygens. A lot of atoms in there. Okay? But in chemistry, we use the mole for that. Okay. So now what you need to do is get this all in one place, ladies and gentlemen. So flip to the next slide. And put this all into one table for yourself. Now, I have added an extra column here. In the metric system, we measure in meter. The U.S. equivalent to that would be to measure in feet. We measure in kilograms in the metric system. In the US, we use pounds and inches, pounds and ounces. So, please copy this down into slide number 21 in your notes, please. I can go see if I have one in the back for you, sir. Marian, with your head down and your computer closed, I have no idea how you're going to know that they're going to ask you this on your test.
Because I can read it.
And that's not going to be up there on test day, by the
I know,
way.
but I know.
Okay. Okay. We'll find out.
Look, I just did it the first one. Look, so look. Second.
Okay. You don't have to explain it to me. You can show it to me on the test.
Milligram, that's mass. Kelvin, that's temperature. Candela, that's light. Amp, that's electric. Mole, that's an amount. Come on, baby.
That's it. You ain't everything right, so we're gonna see.
This will not be on tomorrow's quiz. It will be on the next quiz that you take after tomorrow, but it will not be on tomorrow's quiz, just so you know. But every one of these things, every one of these units, every one of these measurements, every one of these instruments will all give you an observation that is what kind? Quantitative. Everything that you see up there is designed to give you numbers. Numbers. Numbers that if we ask two of you to take and find, you should come up with similar numbers because all numbers are reproducible. All numbers are reproducible, ladies and gentlemen. Okay. If you're not done, I will put this back up there in just a minute. I just want to show you something for if you are done. Because you have 10 minutes left to class, ladies and gentlemen. Okay? In Canvas, there is an assignment for tonight that is a vocabulary worksheet. It is right here in Google Canvas. You click on it, it will take you to a Google form or a Google sheet that it will make a copy of for you and it will put into your drive. What's that? Well, this is in Canvas, but when you click on that link, that assignment, it will open up a Google document for you. Okay? And this is what it will look like, ladies and gentlemen. This one here. So it is multiple choice. Here are the definitions that are going to be on tomorrow's quiz, or some of them, maybe not all. Here are the definitions that go with them. So when you find the definition for hypothesis, whatever letter it is, you put it in here. Type it in. Okay? So type in those letters in there. Now, then there is define a qualitative observation and give 2 examples of it. So again, I'm asking you to define qualitative. Give me 2 examples. You can make up the examples. They can be something around the room, something you see, something you did from the lab last week. I don't care. Then give me the definition of a quantitative observation and 2 examples there. Okay? Amarian, let me get finished, please, sir. Okay? Then we defined what a direct relationship is. It is when as one thing goes up, so does another. So please try to give me an example of a direct relationship from your everyday life or from life around you or some example from science. Where when one thing goes up, something else goes up because of it. Then give me an inverse relationship. And again, here you go. Define chemistry. The last part, ladies and gentlemen, down at the bottom. I give you a unit, you tell me what instrument and what measurement it makes. I give you an instrument, you tell me what unit and what measurement it makes. I give you a measurement, you tell me the 2 that are missing. Okay? This will be helpful for your quiz tomorrow. You've got about 7 minutes now left to the hour. You could get a good portion of this done and you could get it turned in. Okay? You could get a good portion of it done and turned in. You have questions, call me over. I will help you. If you want to work with someone else on this, get with them at a desk. Answer the questions together. It is your choice. Questions? Okay. So please use your time wisely at the end of the hour here. You've got about 7 minutes left, ladies and gentlemen. Thank you very much. That's it. Is it? Yeah, you're just inside the last 5 minutes, so hurry up. Here you go. That isn't going to work for us, so go.
It don't fade.
Marian, you're going to have conversation with your language, or I'm simply going to put you in the back away from everybody where you can't have a conversation with anybody.
She doesn't have the things
Marian, worry about yourself. Okay, if someone else says something, I'll hush it.
Want me to show you where it is? I'm on it.
He is very helpful. Assignment, go into Canvas, go into modules. I'll show you that in 1 second. So here you go. Under the one that says Unit 1 Science Skills, vocabulary worksheet. That's the one you're looking for. Vocabulary worksheet. That's the one you're looking for. Hang on. Amari. Amari. Come here. I know, but you keep. I know kids that have. I swear a lot in summer too. But I have to break it in when I come back from school. You're not. You're logo. There's trying and there's doing. Stop trying and start doing. No, that is an object that holds back water so that you can create a man-made lake. What the hell? Umbrella. Be careful when you hit the button twice on the side here, you get a light on there, you don't. Okay. Thank you. Have a great day, ladies and gentlemen. Now, please go away. Goodbye, goodbye, goodbye. Thank you. What the freeze, Amarian. Give him his phone. Amarian. Hey, Amarian, seriously. That would make you so mad if someone took your phone. I understand, but please don't do that. People get very protective.